a question on identities from the topic trigonometry, and we have to show that the left-hand side can also be written is also equals to the right-hand side or is identical to the right-hand side. All right, so let's start expanding these. So the numerator would be, for the first fraction, a square plus 2ab plus b square. The denominator is cos square theta. And for the other one, it's a square minus 2ab plus b square. The denominators are the same already, so we can take LCM here. And we have 2. And then the cos terms get cancelled, and we have plus 2 sine square theta. Okay. Now what? How do I change this into 2 plus 4 tan square theta? We got 2 and then 2 there, and 2 sine theta and minus 2 sine theta cancels out. How do we get 2 plus 4 tan square theta?
2 tan square theta हो सकता है लेकिन
हाँ, नहीं हो सकता. मुझे लग रहा है there's something off about this question. Because 2 over cos square theta आएगा plus 2 sine square theta आएगा. So let's see. Do we have, we just, let me just look into this. I feel like something is off here. Chalo, we'll come back to this. ऐसे मैं record कर रही थी गलत question. Okay, let's do another one. Give me a second. Doesn't seem right. Okay. This one.
इस वो वाला क्वेश्चन कर सकते हैं.
हाँ, मुझे लग रहा है कुछ गलत है इसमें, क्योंकि वो हो ही नहीं रहा proof. So there's something off. I'll look it up again from the past papers. Okay, because let's see. Let's just try changing this side. So this would be 2 plus 4 sine square theta over cos square theta. So how are these two equal? They're not even close. So यहाँ कोई गड़बड़ हुई है किसी expression की or something. Okay. Question number 4, trigonometric identities. We have to show that the left-hand side is identical to the right-hand side. Let's cross multiply. I'm sorry, take LCM. So the denominator would be 1 minus sine theta times 1 plus sine theta. Sorry, it's x, not theta. This is x, this is x. And then we will have 1 plus sine theta, 1 plus sine x. And because of this negative sign, when this goes here, when this gets multiplied with 1, we get minus 1 plus sine x. So be careful about the signs. So the numerator is 2 sine x. And then the denominator would be a minus b times a plus b is what? That is a square minus b square. So we'll get 1 square, which is 1, minus sine square x. Now this would be 2 sine x upon 1 minus sine square x is cos square x. And now we get the desired form. I can write the cos x terms twice. Cos x times cos x So sin x over cos x becomes tan x. So 2 tan x upon cos x. There are so many mistakes in this worksheet. I need to review it. Question 5 also seems off. So instead we'll do 6. Prove that left hand side equals to right hand side. Let's do that. LCM, which is sine A times 1 plus cos A. Numerator would be sine square A plus this, and this will get multiplied, so it will be 1 plus cos A whole square. The whole square aa jayega, so that would be A square plus 2AB plus B square. Okay. So we know that this plus this is 1, right? And then 1 plus another 1 would be 2 plus 2 cos A. And then the denominator is sine A 1 plus cos A. We can take 2 common from the numerator, 1 plus cos A, and that cancels the 1 plus cos A in the denominator. So we have what was required, 2 over sine A. Okay, question 7 would be probably the last question we discussed today. Prove that 1 upon cos x minus tan x whole square equals to that. Okay, so let's expand. It'll be, let's take LCM first, in fact, so that we get a single fraction. We get cos x 1 minus tan x cos x whole square. Now, at the side, I know what is tan x cos x. This can be further simplified. Tan x is actually sin x by cos x. And then there's cos x with it. So this and this cancelled. So tan x cos x is actually just sin x, right? So the numerator is 1 minus sin x whole square, and the denominator is cos square x. Now I know how to use identity on the denominator. Cos square x would become 1 minus sine square x, right? From the identity, sine square x plus cos square x equals 1. Okay, and the numerator is still 1 minus sine x whole square. Okay, instead of expanding the numerator, what I'll do instead is keep it the same. And I'm going to apply a square minus b square in the denominator. Because the denominator is actually 1 square minus sine x whole square. So what is a square minus b square? Sorry, yes. A square minus b square is a minus b times a plus b. So I'm going to use that identity here and get 1 minus sine x, 1 plus sine x. So this square and this cancels out and we get 1 minus sine x over 1 plus sine x. Now, identity is seldom asked on its own. It is usually followed by a part 2, which we see here as well. So if you're done with part 1, please let me know.
Part 1 में it's 1 plus sin x over 1 minus sin x.
Galti hai. I'll fix it. Unless I did something wrong, let me double check. 1 minus tan x times cos x. Tan x times cos x is just sin x. So we get 1 minus sin x whole square in the numerator. Cos square is 1. 9 question वाला. Should have proofread it before starting it. Anyway, so let's fix that here. This is actually minus and this is actually plus. Okay. In my defense, I don't make these worksheets, but still it was my responsibility to take a look before starting it. Anyway. Hence solve the equation. Hence means we have to use the previous result, which is this below. Okay. So hence means that instead of this, we're going to use this. However, notice that they've changed this to 2x and 2x. So you're also going to replace x with 2x. Inside the bracket, we have 1. Achani, the square will not be written here. And instead of the x, we'll write 1 minus sine 2x over 1 plus sine 2x equals 1 by 3. Okay, now we're going to solve this the typical way. X is between 0 to pi. However, the x we have in the argument of sine is 2x. So we'll have to do a bit of adjustment before we proceed. 3 minus 3 sine 2x equals 1 plus sine 2x. So we get 4 sine 2x equals to 2. So I'm getting half sine 2x. Half equals sine 2x. However, there's a problem, which is that our domain is for x, but the question is for 2x. So we'll have to fix that first by using substitution, which is let y equals 2x. So then x will be equals to y upon 2. So let's replace this. 0, y upon 2 pi. So y is between 0 and 2 pi. Okay. So let's solve that. We have sine y equals half. So alpha would be, what is sine inverse half in radians? It's 1 by 6 pi. So sine is positive because this is a positive value in the first quadrant, in the second quadrant. So we get 1 by 6 pi here and 1 by 6 pi here. So this is the value for y and this is the value for y. So y is coming out to be 1 by 6 pi and the other y is coming out to be pi minus 1 by 6 pi, which is what, 5 by 6 pi. All right. However, we need to solve this for x and not for y. So now we're going to use this conversion, which is when you divide y with 2, you get x. So we're getting x equals 1 by 12 pi and x equals, divide this with 2, which gives us 5 by 12 pi. Which are the correct answers mentioned at the end. That means the part 1 had the sign swapped by mistake. Okay. So that's all for today. I'll send the identities worksheet. You should go over it completely if you can, because this is a frequently asked topic. Her paper mein आइडेंटिटी का क्वेश्चन तो होता ही है, सो आई वुड रिकमेंड इसको खुद कर लो, लेकिन इतना मुश्किल नहीं है, प्लस वी डिड practice it when we were covering the chapter, so I don't want to spend any more time on it. I will instead start differentiation tomorrow. Jiran, you want to ask something?
No, miss.
Dua, you were trying to ask something because I saw someone going mute, unmute, mute, and
No.
acha, chalo,
I
theek. Okay, I'm just imagining things. All right, see you guys tomorrow. Allah
All right,
Hafiz.
miss. Allah.
Take care.
Allah.
Yes. Bye.